Welcome back. In this video, we will be discussing the SI unit prefixes. In fact, some of our measurements can be very large or very small. We can either change how we read the number or how we read the unit. Using the base unit, scientific notation can be implemented to make the number readable, but that can be cumbersome. Another option is to use SI prefixes to replace scientific notation. This allows us to scale the unit to a much more convenient measurement. The common SI prefixes that you're required to know are shown here. Many of these prefixes are commonly seen in everyday lives. The terabyte is a common capacity for most of computers, gaming systems, and internet storage seen today. The gigabyte has been shortened to gig and is the primary unit of storage on cell phones. The megabyte were the usual storage size when dealing with the most recent generation of CDs and floppy disks. And before that, we even had computer storage in the kilobytes. You're probably familiar with the kilo prefix from the kilometer. Many people run 5K races, and this is a distance of 5,000 meters. The smaller prefixes, which are more prevalent in the science, can be found in everyday life as well. Commonly used for a length of measurement, the centimeter is 1/100th of a meter. The milli prefix is typically used in close races during the Olympics when photo finishes are measured to the millisecond. When measuring volume, the milliliter is 1/1000th of a liter. The smallest prefix that is utilized during many chemistry experiments is going to be the micro prefix. The micro prefix is used in biology when trying to study smaller volumes, typically in cells, and a microliter is 1/1000th of a milliliter. The nano prefix is used most often when describing the wavelength of light. The visible light spectrum have wavelengths from 400 to 700 nanometers. However, we even have smaller things that we have to measure. The radius of a typical atom is usually measured in picometers. This distance is 1/1 trillionth of a meter. The femto prefix has become more useful in the past decade with the creation of femtosecond lasers used to determine the velocity of some subatomic particles. So how do we convert from one prefix to another? This math must be done very quickly during exams and quizzes, so we need to come up with a system that will allow us to make this conversion seamless. When we have an SI unit and we want to get to another, we will build a series of conversion factors. Let's start with an example. The radius of a hydrogen atom is 53 picometers. Let's convert that distance into centimeters. We can convert from our original unit to the base unit, and then from the base unit to our desired unit. We know from our list of prefixes that 1 picometer is 10 to the minus 12 meters. So we will build a conversion factor with both of them. We need to put the unit that we are going to on the top and the unit we would like to eliminate on the bottom. We can see that our picometers and picometers will cancel, leaving our unit of meters. The answer that we will get is 53 times 10 to the minus 12th meters. While this is not correct scientific notation, we are still in the middle of our conversion and don't need to worry about it just yet. Now that we have our base unit, we can convert to our desired unit, which is the centimeter. We have our meters. We need to put meters on the bottom and our centimeters on the top. Using our table, we know that 1 centimeter is 10 to the minus 2 meters. Our meters and meters will cancel, leaving us our centimeters, and we will get 53 times 10 to the minus 10th centimeters. Now we can correct the scientific notation for our answer. We must move the decimal place 1 to the left to give us the proper position of n, and this will give us 5.3 times 10 to the minus 9th centimeters. Let's try another example. The volume of a normal E. coli cell is 4.8 times 10 to the minus 12th milliliters. What is this volume in picoliters? We can combine both of our conversion steps into a single mathematical expression. Here's our original value. Going back to our table, we need to find our milli prefix. Milli is 10 to the minus third. So we know that 1 milliliter is 10 to the minus third liters. It gets us to our base unit. Now we have to go to our desired unit, which is going to be the picoliter. 1 picoliter is going to be, if we go back to our original table, 10 to the minus 12th liters. In this case, our milliliters and our liters and liters will cancel, leaving us with the picoliter. And if we put this into our calculator, you will get a value of 4.8 times 10 to the minus third picoliters. This is also incorrect scientific notation, so this is an answer that we would report. With our prefix getting smaller, notice that our number got larger in magnitude. A great rule of thumb is if the prefix gets smaller, the number should get bigger. If the prefix gets bigger, the number should get smaller. Being able to manipulate these values will help you in many of your equations, formula, and can help you understand the magnitude of scale for many of the measurements that we will do in chemistry.